the goal this morning is going to be to 3D print Elon's face. I think it is on a website called Thingiverse, and I was given some instructions by somebody who gave me the idea, and I will look up something called CURA, C-U-R-A, to print out the G-code file. So the Thingiverse, if some of y'all don't do 3D printing, it will create a STL file. And from there you take that and you put it into a slicer, which will give you the 3D printer different sections to print, is my understanding. And I'll be using PLA as a substance to print with. So this is my first time doing this, 3D printing anything. I've done some research with videos already several weeks ago. And this is going to be a good challenge for me. And hope you can follow with me and maybe get excited about printing Elon's face or other things. There's a bunch of files on Thingiverse that you can download, whether it's an engine or different parts, and it's going to be exciting for me to step forward into this field. It is January 1st, 2022, Saturday. Paul Mamakos with Ocean Camera Space Corp. So there's a program called Thingiverse, and that's where we can look at 3D models of Elon's face. Gonna search for it here. I've done this a few times already. So type in Elon Musk. And so there are 2 items here as of January 1st, 2022. And so you can click on the head. It's really just an approximation. To me, it doesn't look like Elon's face, but maybe. Might have to look closer at his face and see if that is. So we click on download all files. And so there's 3 items here. I'm going to download each one. Stereolithography, okay. The STL is what we're looking for. I don't think we need these other 2, but I will download them just in case. This is my first time doing 3D printing here, so I'm looking up the CURA software, C-U-R-A. See what comes up. This is going to be the slicer for the 3D printer STL file, and it will make the G-code file. Okay, got a download for the Windows version. Maybe I'll just see if I can find the actual website. Ultimaker. This looks like it right here. Let's get it. Download for free. Here we go. I'm using a PC right now, so I will download it to the desktop. Okay, the file has downloaded. I'm going to click on it and see if I can activate the file, run it, and install it. That's a good spot. Okay. Okay, it is finished installing. Okay, just got this pop up here. I will allow access to for the CURA to function here. Okay, we logged into CURA here. Let me get started. Accept the disclaimer. Wow, pretty interesting stuff here. I'm not sure what to say about that. The type of printer we have here is a Creality 3D printer. Creality 3D. We have the Ender 3. So you could put in a default printer, or you can add the printer later. I'm going to go with the default settings here. I'm not going to adjust any of this information. Okay, we're in the CURA software. I'm going to see if I can upload that. So here we have the Elon Musk 3D STL file. So open this up. All right, that looks to be it, everybody. All right, so Jack, right?
Yeah.
From MSX is here. He's going to show us how to do this.
All right, so let's help you out a little bit. So let's get the model rotated so the flat part's flat with the bed. And then what we're going to do, we're also going to make it bigger at the same time. So let's go ahead and scale it up right now.
So the first thing he did was to right click on the mouse and then to move his finger on the touchpad.
Yeah, and that's how you pan around. And then now we're going to rotate it. So
we want to put the base onto the floor of the 3D printing model. So that's why he rotated the head, the base onto the base.
Yeah, so the light blue shows that that surface is making contact with the bed, which is important. Now, slice as you did earlier, but let's make sure there's supports. It needs to be supports, because underneath the chin, see where it's red? All the areas where it's red shows where the printer can't print without a support. So just did that. Let's just go ahead and try a slice. I think everything else should be fine, more or less. We're going to slice, and then we're going to transfer this file onto an SD card and try to print it out and see if we get lucky. Alright, slicing, slicing, slicing. And then we're going to send this file to my email, and Paul will get some footage of the printer printing. So there we go, save to disk. Alright, Paul, you can go.
Yep, good.
And Paul's going to take over.
Alright, the next thing we'll have is some images and video of the printing and everything with the micro SD card, everybody. Alright, it's saved. So everybody, if you don't have a micro SD card, I'm just going to email it to him. He has one, but you would need to plug it into your USB drive or whatever, and then the 3D printer uses a micro SD card. So that's the next step. This is the next step. We're going to take the we got a micro SD card here in the Creality Ender 3D printer. So we're going to put it into the micro SD on the computer here. And I'm going to save to file here. We're going to save the file to the removable device. Alright, so that is a done deal. See, this is an adapter from the SD to the micro SD. So the 3D printer takes micro. And put it over here. And
yeah, and that's loading the file. Okay, so now we're just gonna have to print it. So
okay,
we're gonna have to do a couple of things, right? We're just gonna have to do a couple more things there, Paul. Okay, so right now we have the TPU filament loaded in. It's the flexible stuff, but we want to change that to the to the solid silver stuff, I guess.
All right, so this is the PLA filament that we're going to use to do this. You want to say anything about this type of filament? Is it stretchable or?
No, this is just regular PLA. It's not flexible or anything. Flexible stuff would be TPU, but the nice thing about this PLA is that it's shiny. Back when I first started, they didn't make stuff this shiny before,
Okay.
so this, you can make a nice little Elon head with this thing.
So we're switching out to the PLA. Putting the PLA into the 3D printer machine in there.
See the blue coming out the bottom now, right here. See it coming out?
Yeah, push it through a little bit.
See it?
I see some blue, yeah.
There you go. Now that's ready to go. So now, you want to do the honors, Paul, of starting the machine?
Oh, that's all right.
I'll get it right there. And, ready?
Okay, go ahead.
Okay, it's going to heat up the bed now.
Okay.
It's also going to heat up the bed. So right now it's at 30 Celsius, halfway there to 60. And then once that heats up, it'll be ready to go. Target is 60 Celsius. So it should start about any time now. Oh, let me just reduce the heat of the nozzle. It doesn't have to be 220. We can put it at 200. There you go. And that just went ahead and started the machine.
So we've selected the file from the micro SD card and it's heated up to how hot? 200?
Yeah, 200 Celsius.
Okay.
And then the bed is supposed to be at 50.
Celsius, everybody. Wow.
So now it's going to do that line again.
So it's doing it.
On the very edge.
It's doing a test line on the back there.
So now I should draw a perfect circle in the center. And there it goes. Yeah, it's drawing a perfect circle right there, and that's called a skirt. It's just to get the plastic primed to make sure it's ready to go for the next part.
So that is on the screen, that's a G-code. We're not working off of the computer right now, so this is entirely off the micro SD.
So now it's printing the actual part now.
Okay.
That smaller circle, and there's the actual file that you made.
Cool.
See, now it's filling it in.
Okay. Well.
Since this is PLA, if we were like really in a hurry, we could speed it up a lot faster.
Okay, this can move faster, you think?
It could.
Okay, wow.
You want to see it, maybe?
Yeah.
So it's double the speed, because we're being silly.
So we can move it faster, everybody.
Yeah, just for fun.
What feature did you just change?
I just sped it up, the percentage. You hear the motor?
Oh, okay.
Higher pitch now.
Okay, wow. Okay.
Huh? Because it's moving faster. See, it's moving faster now.
Cool. Twice as fast. Wow.
And supposedly, when you print faster, it reduces the quality a little bit.
Okay, reduce the quality. Okay, good.
But it should be alright.
Alright.